Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is to talk about systems of two-dimensional inequalities. So not the one-dimensional ones. So we did talk about these for a while. These are the ones that you answer on a number line, right? Just to kind of, maybe I'll do this one really quick. So we would have minus x squared. We'd have a minus 4x in there. We'd have a plus 4, plus 1. And then we got minus x squared plus 4x minus 4 plus 1. So then minus x squared plus 4x minus 3. And then we want the roots of this thing, right? We want to know first when it equals 0. And so I would personally multiply this thing by -1 just to make it a positive quadratic. And then it's one where you can actually factor it, because you can do x minus 3 and x minus 1. And so the roots are 3 and 1. So these were the problems where we plotted the roots. So in this case, 1, 3. And then, now I've made it so it's an open up quadratic. And then I think about when is the graph. In this case, it says, when is it greater than 0? And it's greater than 0, kind of here and here, not including these spots, right? So this would be an OR problem, and you would say x bigger than 3 or x less than 1. That's how it is if it's a one-dimensional problem. But we're talking about a very different thing here. We're talking about a two-dimensional thing. So this is where we'll have to shade in 2 dimensions. So we would need to graph this quadratic and then shade the y values that are less than the graph. So what this will look like, we have vertex form, shifted over 2, up 1, right? You'll need to plug in like some kind of easy point. An easy point could be like x equals 1, right? If you plug in x equals 1, you'll get 1 minus 2 squared plus 1, and then that'll be actually working out to be 0. So if you plug in 1, right, you get 0, which means that over at 3 you would also get 0 because of the symmetry. And because it's a less than, we're going to get a dotted line. And then we want to graph all the y values that are less than it, right? So, if I was at any point like here, I need to shade down. If I was here, I need to shade down. The y values below, y values below, y values below, right? And you just get this. So, very different kind of problem. Technically, this could be understood as shading too, but it's shading on a number line. Whereas here, this is shading on a two-dimensional graph. And so what we're really going to do today is going to look at systems of quadratic inequalities. So this kind of thing, but mixed with another type of graph. All right, so systems of quadratic inequalities. So really the only difference here is that we're going to have, we have to use what we learned about graphing quadratics to graph the system. So you'll see in the homework problems, there's some quadratics in every problem. And, the only new part here is really just using what we learned about graphing quadratics, but the rest of it's basically the same, where the solution to a system of inequalities is still just the overlapping region between the 2 or 3 or 4 or however many inequalities you got. So let's just get into it. So I think what I'm going to do for this first one is just move the 2x over, okay? So we'll really have y is greater than 1/2 x squared plus 2x. And that's in standard form, but it honestly would be kind of nice to actually just turn it into factored form because it factors so easy. It's one of those where you can just pull an x out, and you would have 1/2 x plus 2 left over. And so you know the roots now. You know one root is 0. And then if you think about this one, if you solve that factor for equal to 0, right, you would, oops, I just realized it should be minus 2 in here. Sorry. I subtracted it to the other side. Okay. So if you would like add 2 over and then multiply by 2, so you get 4 is the other root there. And so I guess I'll graph this one in red because that's the color I got open right now. So I got 0 and then I got 4 over here. And so you know the line of symmetry is like cutting down through 2 here. And so you can just plug in 2 to that quadratic, 2 times 1/2 times 2 minus 2 to figure out the y value of the vertex. All right, so now we've got the first one graphed. And we know it's a greater than problem. So most importantly, I guess what I'm thinking of is we would do a dotted line, or dotted curve, I guess. I'm going to get rid of the line of symmetry too, we don't really need that. Then the other one, I think I'll just do this one in green. The only thing you really got to do this is multiply by -1. Remember that you'll flip the inequality if you multiply by -1. And then, I've distributed it to both terms on the right side. And then it's just an absolute value. It's got a vertex at 1, 1, and then it's got a stretch factor of 2, and it's also going down. It's like an upside down one. So we would go down 2 over 1, down 2 over 1, and this one is also a dotted one. Because it's not equal to. So we need to be above the like caret symbol, and we need to be below also above the quadratic. So basically what that means is if you're above both, then you're going to be kind of in this general region right here. So that purple area is like the solution. And you can always like check these problems, right? So like you can plug in 2, like for example, 2, 2 into both, and it should work. Just because that is, a point right there in the solution space. You could also plug in points that don't work and make sure that they don't work. You could plug in 1, 1. It should not work because it's not part of the answer. It's dotted on the green, so it won't be part of the solution for that. You could plug in the origin, and the origin shouldn't work. You could plug in like 1, -2, and that shouldn't work. So it's good to kind of sell yourself. Obviously, there's an infinite amount of points here, so like you can't plug in all of them. There's also an infinite amount of points that don't work. So you can just try a few just to make sure that your area actually is correct. All right. I figured if we're talking about systems of inequalities, we should probably also talk about quadratic systems of equations. So, and they're really, this is actually going to be like the solution over here. You're going to see in a second. But it's probably not too hard to think about, like if you've got a quadratic, right, then this is just a line. If we think about a system of equations here, we could get 2 solutions, right? Because the line could cross and hit in 2 spots. It is possible that you could have like a purple line or something going like that, and it could be steep enough that this grows faster than this comes down, and so you could get it so like you could have one solution. You could also have a line that just hits through the vertex and gets one solution. That would be one solution. This would be one solution. You could also have a line that's just kind of over here, and it could have no solutions, right? So in these problems, if it's an equation, you can actually have 0, 1, or 2 solutions to them, which is kind of a good thing to just kind of make sure that makes sense to you. I'm going to get rid of all these so we can see the problem a bit better. Okay. And honestly, the normal tricks still apply, like substitution, elimination stuff. So I would probably do substitution because we have this solved for y, and you could just go and plug it in, right? So basically I'm just going to stick it into the other equation right there. So 2x plus, that's an x, 2x plus 1 would equal negative x squared minus 8x minus 15. Probably would go ahead and take all of this and move it over to the left because I want to keep the quadratic term positive. If you do that, you'll get x squared plus 10x plus 16. And then it's actually nice because it factors. If you think about multiplying to 16 and adding to 10, it would be a 8 and 2 situation. And then the roots, the roots of that quadratic are negative 8 and negative 2. And so now, this is where it's kind of deviating from systems of equations before. You actually have to sub in 2 times, right? So there's kind of like 2 cases, like x equals negative 8 and x equals negative 2, and both could work. If you plug in negative 8 to like the first equation, y equals 2 times negative 8 plus 1, you're going to get the negative 15 case. And if you plug in negative 2, then you're going to get the negative 3 case, right? And so this point is right there, and this point is right there. So there's 2 solutions right here and here are the 2 solutions, the 2 points of intersection. So I just thought we should see some of those too if we're talking about systems. All right, so just one more problem. It's important to make sure you can still write equations of graphs, inequalities, whatever, given a picture. So kind of the reverse sort of problem. So I personally, if I'm doing quadratics, I would do everything in vertex form because you get, if the vertex, I guess, is a nice point like it is here. So we know we have something of the structure x minus 4, all of that squared. I'll put it, but I'm going to stop writing it soon. So we know the vertex is 4, 0. So using like what we know about transformations, we would have negative 4 in there, and then we'd have plus 0 on the outside. And we really just need to get this a value, this like vertical stretch. So this is where you have to use like another point. You could use this one, right? You could use 3 comma negative 2. And if you just plug in the negative 2 for y and the 3 for x, you should have an equation that you can solve for a, right? So if I do this thing out, negative 2 equals, a, in there you got a negative 1, but then you square it, you really just get like a 1, right? So it's saying a is negative 2. So then my final answer, so we know it's actually, I wrote this kind of wrong, but it doesn't really matter too much. It was a less than, right, or equal to, because it was a solid line, or solid curve right here. So we know we have less than or equal to negative 2 times x minus 4, all of that squared, and then plus the 0, but we can just leave it off, right? And if you go check it, if you go like plug this thing in to Desmos or something, you will get that graph right there.